Now that we've talked a little bit about the different RAM types, SDRAM, Rambus, DDR, DDR2, and DDR3, we need to know a little bit more about something called error checking. My apologies. Error checking actually allows our RAM to take the memory that it's using, take each of the bits, and it adds a last bit on the memory in order to do that error checking. Either we have parity or we have ECC, which is error correcting code. Now, that last bit is basically our checksum. It allows us to take all the memory that is before that and use, say, 8 out of 9 bits for actual memory that we're storing, and then the 9th one is what helps us with the error checking. Now, memory that error checks is a bit more expensive than just standard memory, and of course the reason for that is the extra bit. Now, the extra bit, while it is a bit more expensive and it also may slow down the RAM some, there's the trade-off there. The extra payment as well as a little bit of slowness allows us to determine, do we really need that in comparison to how stable we want the memory to be and how much we want to make sure that everything stays good in the memory. The two types of error checking, parity and ECC. Our first one, parity. Essentially what parity does is it takes the first 8 bits of information, and these are all either ones or zeros, an on or an off. And we add a 9th bit for error checking. It's our checksum. And the 9th bit is called the parity bit. All 8 bits plus the 9th bit are all added together, so we have an entire value. And then if the final value is odd, then it's okay. That's our checksum. We want that checksum value, the value of all of these plus the parity bit, to be odd. If it's not, then we can get a parity error on our computer and it'll stop. Now again, this is with only memory that supports parity, and it's more expensive than regular memory. The other type of error checking, ECC, stands for error correcting code. This type of error correcting actually doesn't just check the memory and see if it's right or wrong and then shut us down and give us an error when it's incorrect. It actually tries to correct the problem if there is one. Now, the error correcting code is the most expensive out of the two type of correcting, and obviously why, because it auto corrects by itself, or at least attempts to, but again, it'll slow our performance. So expense and slower performance versus better memory and better error checking. It's a trade-off. So it's always something to consider, especially in an environment where we need to have that consistent memory.